So again, we're going to be talking about right triangle trigonometry again, but specifically to a 30, 60, 90 triangle. When you work with a 30, 60, 90 triangle, there are definite values for the sine, cosine, tangent of 30 degrees and definite values for the sine, cosine, tangent of 60 degrees. And it always works. I mean, you can go ahead and plug it into your calculator and it's always going to work. And it's a precursor to the real complexities of trig. But we're not there yet. I went ahead and I wrote you a hypothetical, well not hypothetical, the general formula for a 30, 60, 90, where 30 is x, 60 is x root 3, and 90 is 2x. And I did SOHCAHTOA, so that's pretty cool. Yeah, that's pretty much it there. So the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So with that said, if I want to find the sine of 30 degrees, it's the, now, here's the thing, I'm not using sine of theta anymore because I'm actually given the angle. So instead of like the theta measure, I'm given the angle. So now, if I want to find sine of theta, well, what it is it's x over 2x. It's opposite over hypotenuse. This would be the opposite, that would be the hypotenuse. That's x over 2x, which is the same thing as 1/2. The x's, cross out, become 1 over 2. And you can check it. Sine of 30 degrees in your calculator is 0.5, but you wouldn't put 0.5, you'd put 1/2. Why? Because you want exact values, not, arbitrary values. Use a different marker here. This one's running out. Cosine of 30 degrees is the adjacent side. It's not this side, that's opposite. It's the adjacent side over the hypotenuse. So it's x root 3 over 2x. My answer is square root of 3 over 2, which I think is like, I don't know, 0.866 or something like that. It's pretty close to that. So it's square root of 3 over 2. And you wouldn't write 0.866. So when you put that into your calculator, cosine of 30 degrees, and you put 0.866, and you don't know why your teacher marked it wrong, it's because they want this answer. They don't want the decimal answer. And what I used to do when I was a student is I just memorized 0.866 was root 3 over 2. I knew 0.5 was 1/2. Everybody knows that. And like if I got 0.707, it's, okay, that's easy. That's square root 2 over 2. I actually memorized the decimals. I mean, you could do that too, but it's best to actually learn what's going on. The tangent, and in this case we're doing the tangent of 30 degrees, is equal to the opposite over the adjacent. So it's x over x root 3. Those cancel, and you're left with 1 over the square root of 3. But your teacher says, make sure you rationalize the denominator, so you actually have to rationalize the denominator. No square roots in the denominator. You can't, it's illegal to divide by anything that's not a natural number. So multiply by the square root of 3 on both the bottom and the top, and you get square root of 3 over 3. Pretty cool. Sine of 60 degrees is, now we're going to be working with this angle, we're not working with the 30 anymore, is the opposite over the hypotenuse, which is x root 3 over 2x. I'm going to point out something that I think is pretty fascinating. Let you digest this though. Some people might see it, but maybe they won't. The cosine of 60 degrees, right here, is my adjacent side over my hypotenuse, which is x over 2x. Which equals 1/2. A little lazy here actually. The tangent of 60 degrees is opposite over this one. So it's the opposite, which is x root 3 over x. Which is root 3. Something pretty interesting about the sine and the cosine. Not with the tangent. It has to be tangent and cotangent. It doesn't work with tangent 30 and tangent 60. That doesn't work. But what's really interesting with the sine and the cosine is, and I said this before, is that the sine and cosine are co-functions. And basically all that means is this. Sine of 30 degrees is the same thing as cosine of 90 minus 30. Are you sure? Positive. I know that the cosine of 30 is root 3 over 2, so I know that the sine of 60 is automatically root 3 over 2. What that basically means is this. It falls under this formula right here. And this works with sine and cosine. It works with secant and cosecant, and it works with tangent and cotangent. But basically, all it reads is this, that the sine of, pi over, didn't actually teach radians yet, so that's not going to work. The sine of 90 degrees minus theta, we'll call it, equals the cosine of theta. Basically, all that means is this. Let's say theta is 30 degrees. Let's just say it is. So 90 minus 30 is 60. So the sine of 60 is going to be the cosine of this. That's how it works. And that's on right triangle trigonometry. So the sine of 45 is going to be the same thing as cosine of 45. The sine of 20 is going to be the same thing as the cosine of 80. The sine of 5 is the same thing as cosine of 85. It just works like that. They work in a complementary fashion. So, 30, what else will be, what 30 plus what will be 90, 60. So 60 and 30 will work when they're cofunctions. Simple as that. So if I put the cosine of 20 and I figured it out, it would be the same thing as the sine of 70. I hope I said that right before. I hope I didn't use 20 and 80. That'd be really foolish, actually. So it's a 90 degrees, which adds up, all that good stuff. They're cofunctions of each other. Pretty cool. So I don't really even have to think about it. I just kind of know. And the same thing with you, maybe. So you have to actually memorize these, especially sine of 30, cosine of 30, sine of 60, cosine of 60, tangent of 60, and tangent of 30. These are actually things that you have to put to memorization. And if you don't know how to memorize them, that's fine. You have to memorize this bad boy right here. You actually have to memorize a 30, 60, 90 triangle. I'm going to work with 30, 60, 90 again, except I'm going to work with cotangent, cosecant, and secant. We'll see how that goes, but for right now, have a great day. Goodbye.